Welcome to our pre-event webinar series for the Reliability and Maintenance Congress 2024. Today, we have the pleasure of speaking with Mr. William Holmes. He's a leading expert in root cause analysis, and he is the CEO of RCA Rt and RCA2GO. Do you mind if I call you Bill?
I prefer you call me Bill. Everyone calls me Bill.
Great. We are also in the company of greatness here. Jesus Cifuentes from PDM Tech is here as well, and he will help us conduct the interview. Hello, Jesus.
You can call me Jesus instead of Jesus.
All right. Jesus gives you
everybody calls me Jesus.
Okay. All right. So again, thank you both for joining. Bill is in another dimension. He's actually talking to us from the future. Where he is, it's Friday morning, and where we are, it's Thursday evening. So this is an unexpected surprise. So Jesus, can you take it away, please?
Yes, sir. It's my pleasure to have Bill again here in a meeting. So we have had many meetings, Angel, over the last couple of years. And all of the meetings have been in different dimensions, as you say.
Okay.
So it's always nighttime here in the East Coast, and he's in the following day. So we are used to this dimensional stuff, and we have been dealing with that for some years, working together, a couple of interesting projects. So again, it's a pleasure to have Bill, and let's start with some questions we want to ask him. So Bill, just to start, tell us, we have, given some tipping off already, but tell us, where are you from?
I'm from Australia, and I apologize for my accent. I hope you can understand okay, but I live in Melbourne, which is down the southern side of Australia, and for us, we might be ahead of you. We're 14 hours ahead of you in New York, but we're in midwinter, so I kind of envy you your better weather at the moment.
Yeah, it's pretty hot. It's pretty hot here, so we better be there. So
on average, we're okay. You're too hot, and I'm too cold, but on average, we're okay.
Before we speak about work and about business, let us know, how do you guys have fun there in Australia? What do you do for fun?
Oh, well, lots of different things, of course, but my hobby or my passion is flying, aviation. Early on, I got a commercial license and instructors rating and all that sort of thing. So, and I'm in a syndicate, the oldest syndicate in the country. It's been running for 60 years. So my passion is aviation.
Okay, so you do aviation for fun.
Yeah.
I thought you were going to see a penguin chasing.
So tell us about any interesting story about aviation. I know you have done aviation in many countries in the world. Is there a special one you want to share?
Oh, I don't know. We actually bought a little plane in Oklahoma and flew it across to Los Angeles one time, across the Rocky Mountains, and it had an open cockpit, so flying over the Rockies, the wind can get up. At one stage, we were only going across the ground at 18 miles per hour. So it was an awesome trip. It was huge fun, but quite challenging. Yeah,
that's quite of an experience. So, and you're happy to tell that to us today. So, could you share some information about your background? So, are you an astronaut? Are you an engineer? Are you a biologist? Tell us about your professional background.
Oh, I trained as a mechanical engineer and worked in oil and gas industry for several years, and power stations, and in manufacturing for several years, and in reliability roles, commissioning roles, and also was a planning supervisor in a planning office for about 3 years. And then in the 90s, I started working for a company that was funded by the government, and it was intended to find what was best practice around the world. So we brought together around 300 of Australia's leading companies, and we run about 300 events a year to share knowledge, usually at sites. Might be a planning department, and different planners would come from around the country, and that led into a benchmarking exercise using the DuPont process. We collaborated with Ed Jones from that company and did studies across 5 continents for different large mining companies particularly, and to try and establish what was best practice, what actually works. You hear a lot of people say things, but what really works? So we tried to quantify that and then feed it back to our members, and that really led to me to realise the importance of problem solving, because if you actually eliminate the root cause, you eliminate work and free up people to do other work. So that got me interested in root cause analysis and problem solving, and so I've been working on that for the last 25 years.
So that's interesting. So Angel and I know that you are a root cause analysis guru. I know that you don't call yourself a guru, just you are a humble guy, but Angela and I know that you are. So I know that you have done hundreds of important RCA Rt exercises in many countries, and especially you have done a lot also in Australia, in your own country. Do you remember a success story that you want to share with our community? They are eager to learn how RCA can help them drill down to the crux of a problem and solve it. Anything that comes to your mind that was really impactful in one of your customers' facilities?
Well, I'd like to share one actually from my own experience back when I was a young engineer, so you can tell that was a long time ago. But I was working in an oil and gas facility, and there was a number of fractionation columns in the facility, and they need to circulate liquids, propane, butane, and so forth, at low temperatures, minus 50, minus 70 degrees C. And typically they have a row of pumps. You might have 20 pumps all in a pipe rack, and these pumps the seals were failing only with once every year on average. And but if you've got 20 pumps, that means the seal's failing every 2 weeks. And to change a seal in that sort of environment, it's a lot of work and a lot of hazard. Anyway, this had been going on for a year and a half, and the maintenance guys had checked, soft foot and alignments and hot alignments, you name it, and really got into it. But this problem kept existing, and finally, someone threw the job to me as one of the plant engineering guys, and I went and looked at the components that had failed, and I saw an O-ring that it looked like it had extruded a little bit, affected by heat. And of course they're double seals with a barrier fluid between. So I wondered if somehow there was a braking effect creating heat. And everybody sort of laughed, these things, they're common in the industry, and that it's impossible for the barrier fluid to increase in pressure. Nevertheless, I asked for a chart recorder, a simple wind-up chart recorder, little pen thing with drawing lines on the paper, and put it on the barrier fluid circuit, and the pressure just stayed the same for days and days. And in about 10 days, it had one spike, and the fault didn't become evident because the barrier fluid may leak into the product. So the fault only was visible a few days later. But then there was a spike on the time chart, and this when we looked at the time, it was around dawn, and so then we started thinking, what's happening around dawn? The sun comes up, and it turned out there was a 50mm pipe in the pipe rack, stainless steel pipe, and this is out in the desert, and in the desert it gets very cold at night, so the pipe was cooling down overnight, and as the sun comes up, it would shine on the pipe and increase the pressure, increase the barrier fluid pressure, force the seals together, and create heat. The O-rings would fail, and then it would just start leading a little bit of seal fluid, and then a few days later they'd figure it out. So why that story is, it really taught me a lot about root cause analysis. Evidence is king. Our assumption, the assumption of everybody was that the barrier fluid couldn't increase in pressure. There's nothing to make the pressure higher than design, and the circuit had been used in so many different plants. So, but when you get to that point where you can't, you've tried all the normal things, then you have to find evidence to test your assumptions. Then intermittent faults are invariably due to several different things happening. We needed, for that fault to appear, you needed a pipe that was not shadowed by other pipe work, and you needed a cold night, radiant heat, and then you needed the sun to come up on a day when there's no cloud. And of course, so when you've got an intermittent fault, you've got several different things, and that's the Boolean and. You've got different things adding together, and so evidence is king, and look for those. Some people call them conditions, we call them combination causes, things that combine together to lead to that fault. Anyway, that's my little victory that I had there, but I thought I learned so much from it. And I felt really good. Saved hundreds of thousands of dollars, and the fix was a little safety valve that just popped off when so the fix just cost a few $100, and I was a hero.
Sure they were losing a lot of money that could be solved with a very cheap fix. So and that was matter.
But if you don't find that root cause, then you get to do the work every 2 weeks and have a team of guys out there making it safe and replacing the seal, and
was the downtime and all of that cost involved. So somebody at some point is gonna ask, what is the beef? What's the benefit of applying such and such? If we're talking predictive maintenance, we're talking RCM, we're talking RCA. Somebody up there is gonna ask, where is the beef? And you get very happy when you can say, or you can prove that what you have done renders a lot of benefit for the company. Yeah. So Bill, we are gonna have the pleasure to have you in this hemisphere, in the other hemisphere of the world, and have you talk about some topics. So can you tell us, what are you talking? What will you be talking about in our Congress? So what's going to be the topics you will be sharing with the audience? What to expect from you and during those days in Puerto Rico?
Well, of course, I'm going to be talking about problem solving, but that's a big topic. And a few of the things I want to talk about is the power of analytical thinking. We normally think by using intuition. We use our experience and our biases to choose between those experiences, and we do it really quickly, unconsciously. In fact, we can't stop ourselves doing it. So we jump to conclusions. So how do you stop yourself from falling into that trap? But how do you stop other people and help them move to a more analytical way of thinking when they need to? Intuition works really well, and it's fast and efficient, So it's fine to use it most of the time because most of the problems are easy. But when you discern that, hey, it's moved to another level, how do you routinely go to a stronger level of doing things? So the power of analytical thinking, I'm going to be talking about that. One of the key techniques is to use the 5 concept that was developed by a Toyota 100 years ago, and it's been used now around the world. And that's a trick to help yourself and other people move to a more conscious way of thinking. And when you're working with teams and by yourself, brainstorming is important, and how to develop and use different brainstorming models. Different brainstorming models help in different situations. For example, if human factors seem to be important, then there are certain brainstorming models that help with that. Whereas if it's you're working with, say, a pump or a motor or some other piece of equipment, different models are helpful. So, and of course you can customize to suit your particular industry. And of course, in that mix is artificial intelligence. So of course we've been working in that area, and we'll be sharing some of the things we're learning, and there are some obvious potential strengths, but there are also weaknesses in it, and so it's important to know the potential, but also some of the traps. And so I'm talking on those topics. Hope that people will enjoy them.
Yeah, and I see that you are enjoying what you speak right now.
I'm passionate about this topic.
And that's really contagious. So I see Angel smiling at myself, because that's really interesting. And what I also perceive, Angel, tell me if I'm right. So Bill seems very confident of when he speaks about RCA and about all of those topics included within the RCA environment. And Bill, how do you think, or why do you think this topic is so relevant in today's asset management environment? Because how do you think that it is going to help people in the industry?
If you don't really know what the real problem is, you come up with a fix. You have to run the plant, so you come up with a fix, but it may not be the right one. For example, you might find there's a pump failing every year, so you work out some technique to make it work, and you every year you go out and do that job, and then the problem goes away. So in a way that's good, but it means that you're spending that money every year to fix that pump. Now, if you had time to look at it more deeply, you might find the real problem that's causing that pump to fail, like I was describing before. And if you eliminate that failure, then you don't need to do that work every year. And planning, we're trying to satisfy production, so we plan all these tasks to go and put in a fix. And very often the planner doesn't have time, and he's not close enough to the job to really know what the real problem is. But he comes up with a fix. And after a while, your planning system can actually be full of a huge amount of work that's costing money and chewing up resources. And then you don't have it's like a sink. It robs you of energy. People blame each other. Things are costing too much. So it's a morale issue. Really bad news. On the other hand, if you can find the real problem and solve it so it doesn't happen again, then that eliminates some work and frees up some money, some resources, so you can spend more time and you find another one, and then you eliminate that fault. And this is a virtuous loop. Suddenly the plant's running better, it's more reliable, people are getting on better because they're not blaming each other. And so it's a real virtuous loop. And I've seen organisations go from, costly and not very productive. And in those situations, people are pretty angry with each other. And but if you can change that around, and very often it's the guys on the front line who have the answers, because they're the ones that see how the metal's worn or what's actually happening, and they feel good about themselves because so their morale improves, their feeling between people improves, they're proud of what they do. They say, wow, look how clever I am, I found that thing and that saved the company a whole lot of money. So
Bill, if I may,
what's that?
If I may, one thing that comes to mind is that, or perhaps my question is, how much of your practice and your experience is purely technical versus how much of it is human nature?
It depends on the field. I said that my hobby, my passion is aviation. Now, human factors is huge in aviation. It's the predominant cause of failure, and it's very hard to actually conduct a flight without making some errors along the way. Minor errors, but they add up, and they. But in plant and equipment, very often it's the equipment itself. You bought a pump off the shelf and it's not exactly right for the situation, or it hasn't been installed properly. Now, you might say poor installation is a human problem. They didn't make the foundation properly. The base plate wasn't stiff enough. You'd say that's a human issue, but generally speaking, once it's there, it's really a technical issue. The international standard on root cause analysis actually says there are two approaches to problem solving, and one is best set up for the technical side, and the other one is best set up for human factors. But I'm probably drilling down a bit too deep into the theory now.
That's fine. Don't worry. You'll have plenty of time to dig down into the theory when you get here to San Juan.
Yep. So I look forward to that very much. I haven't been to Puerto Rico before, but Jesus tells me it's the center of the universe for all sorts of. For the most part, it is.
So we're happy to have you today in this interview, and of course to have you one of the main speakers in our Congress in Puerto Rico. I know that our community is gonna benefit a lot from your speaking, and there will be some customers that you already know sharing experiences, sharing also benefits on their own from the knowledge you have gotten straight from you from RCA. So we're very excited to have you there, and this is going to be a great event.
So thank you, Bill, for joining us today. We appreciate you getting a little earlier today just to meet with us. And then obviously Jesus and myself, we're at probably the last hour of our working day, but it's such a pleasure. Looking forward to seeing you in October 29th and 30th on the beautiful resort that we have chosen for this event in Dorado, Puerto Rico. So thank you so very much.
Thank you, Angel, and Jesus, I really appreciate the opportunity. I'm really looking forward to it. And look forward to meeting everybody there. Thanks very much.
Great, thank you.